Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over how to find the asymptotes and intercepts of a rational function. So the instructions are, for the given function, find all intercepts and asymptotes. So let's say we have the rational function f of x equals 2x plus 5 divided by x squared minus x minus 20. All right, so the first thing we want to do is find the y-intercepts, okay? So let's find the y-intercepts. So to find the y-intercepts, all you simply do is you set all the other variables to 0, okay? All the other axes. So in this case, this is two-dimensional. We have just x and y. So for the y-intercepts, you set x to 0 in the function. Okay, so let's call f of x y. So the y-intercept is going to be equal to 2 times 0 plus 5 divided by 0 squared minus 0 minus 20. If we simplify this, we'll have 5 over negative 20, which reduces into negative 1/4. Okay, so that's your y-intercept. And then how do we find our x-intercepts? To find our x-intercepts, we're going to set the other variable, namely y, or f of x, to 0. And then solve for x, okay? So let's go ahead and do that. We're going to have 2x plus 5 divided by x squared minus x minus 20, set that equal to 0. All right? So we can express these as a ratio. So put this over 1. Cross multiply. If you cross multiply, you'll have 2x plus 5 is equal to 0. And then if you subtract 5 and divide by 2, you have x equals negative 5 over 2. So there goes your x-intercepts. Okay, so let's go ahead and write them down. We have our intercepts. Intercepts are 0, comma, negative 1/4 for the y-intercept, and then negative 5/2 and 0 for the x-intercept. All right, so this is the y-intercept, and this right here is the x-intercept. Next, we have to find the asymptotes. Let's start by finding the vertical asymptotes, okay? So to find the vertical asymptotes, we are going to look for what makes the function undefined. Okay, so what makes this rational function undefined? It's undefined when the denominator is equal to 0. Okay, so also we have to ensure that we do not have any removable discontinuities included. So we have 2x plus 5 divided by x squared minus x minus 20. All right, so the numerator is prime, it cannot be factored, so let's factor out the denominator. So if we factor out the denominator using the x game, AC is negative 20 and B is negative 1. So we can use 5 and 4. Negative 5 and positive 4 works. So this becomes x minus 5 times x plus 4. Now the importance of factoring and reducing is that the vertical asymptotes are the irreducible denominator factors, okay? So if we have anyone that cancels out, that is not a vertical asymptote. That is a point or removable discontinuity. So in this case, nothing cancels out, so we extract the denominator as it is and set it equal to 0 and solve it to get the x coordinates of our vertical asymptotes, okay? The equation of our vertical asymptotes. So set this to 0. We have x minus 5 equals 0, or x plus 4 equals 0. And then if you solve this, you have x equals 5 and x equals negative 4. Those are your vertical asymptotes. And then for your horizontal asymptotes, we simply take the limit as x approaches plus or minus infinity. All right? So we're just going to take the limit as x approaches plus or minus infinity of the function 2x plus 5 divided by x squared minus x minus 20. Now the nice thing about this function is if you're going to infinity or negative infinity, you still get exactly the same answer. Well, how do we know? If you look at the weights, you notice that this is bottom heavy. So this limit in essence is the limit as x approaches plus or minus infinity of um, the term with the highest degree or the leading coefficient on the numerator, which is 2x, and then the term with the highest degree in the denominator, which is x squared. At infinity or negative infinity, these are the ones that grow the fastest. If we reduce that, we're going to have the limit as x approaches plus or minus infinity of 2 over x. All right, and then when you plug in plus or minus infinity, 2 over plus or minus infinity is simply 0. Okay, so there goes our horizontal asymptote. So let's go ahead and write down our answers. Vertical asymptotes is x equals 5 and x equals negative 4. And then your horizontal asymptotes is y equals 0. Okay, so that's that.